Welcome, everyone. We're going to continue our exploration of applications, this time looking at infrastructure and the general system. Our first speaker for the session is Elizabeth Bondi. She is a doctoral student in computer science at the University of Southern California, USC, and is going to talk about video labeling in automatic video surveillance. Elizabeth.
Hi, everyone. Like Susan said, I'm Elizabeth Bondi from USC, and I'll be talking about video labeling in security domains. Before I get into that too much, I'd first just like to mention some of the things that USC is trying to do in the data for good arena. We have a new center in artificial intelligence in society, which is joint work between the schools of engineering and social work. And the main goals are to use AI to solve tough social problems, such as those grand challenges of social work or UN Sustainable Development Goals. And some of the main projects that we're working on in this domain right now, first is AI for low resource communities. Our main project here is working with HIV prevention information in networks of homeless youth. And we actually have been doing some real-world pilot tests trying to optimize the spread of that information. We also have been doing game theory to help protect things in the public, such as the Staten Island Ferry and also airport security checkpoints. But the main thing I'll focus on today is actually AI for Earth. And we've mostly been working towards anti-poaching and some of the security questions related to that. So that's what I'll get into now. Like I said, doing anti-poaching, poaching has become a major problem, especially in Africa, with species such as elephants and rhinos. So to try to combat this, one of our collaborators called Air Shepherd is a non-governmental organization, and they are using unmanned aerial vehicles, or UAVs, to try to be able to spot poachers. So what they do is they fly these UAVs at night, and they have people monitoring video in the van. And if they see any poachers, since poaching typically occurs at night, they'll try to alert a park ranger, who will then hopefully be able to go find the poacher before they're able to hurt any animals. One of the problems of doing this at night, even though it allows us to see poaching actually occurring, is that we have to use thermal infrared imagery to do so. And we also have to have people monitoring this video all night long. So I have a few examples of some thermal infrared imagery that shows people, and I've highlighted on the bottom row where they actually are. And it's pretty difficult to see them, so you could imagine watching this overnight, you might miss some things. So we propose to try to do this automatically. And we actually have a prototype deployed with Air Shepherd in the field at a testing location right now. And this is just a clip from that. And to do this, we used deep learning. But one of the problems of using deep learning is that you need a lot of labeled data. And with our thermal infrared data, there's not a lot of it out there right now, and it can be difficult to label this data. So we developed our own video labeling application, which we called Viola. And that's what I'll be talking about the rest of the time. In developing Viola, our goal was to first and foremost get accurate labels. And we also want to make sure that we don't miss anything by getting exhaustive labels. We'd like to do this efficiently because we want to get as much label data as we can to train a good model and be able to try to deploy this quickly. And finally, we would like for this to be secure. You could imagine that if we use a site like Amazon Mechanical Turk, for example, that maybe a poacher would be able to access some of this data that we're trying to use to train an algorithm, and they might be able to see some kind of information like where we're flying or maybe how many people are on a park ranger team or something like that. So to try to keep our application secure, we have password protected it. And once you get through the password, you see something like this. So on this side, we have a thermal infrared frame which actually has 2 animals. And we are going to label these objects of interest using bounding boxes, and we then just color code them for a label. And we are focused mostly on poachers, but we are also interested in animals because knowing where animals are might also tell us where poaching will be. And some of the controls are down here to submit it. Feel free to look in the paper for more detail on that. Also part of this, we have that labeling interface. We also have a framework that allows us to try to get the most accurate and exhaustive labels that we can. And we first have somebody use that labeling interface to label the videos, and then we actually have another person review those labels. Since it's such tricky data, we want to try to make sure that it's checked before we use our final labels for training. It wasn't always like this. We actually first started by having 5 different people label a single video. And the goal in that was, again, to get the accurate and exhaustive labels. But we also had a goal of efficiency. So we made a few changes through the development process to try to get the most efficient system possible. And I'm not going to go through all of these changes right now. They're all in the paper. I'm just going to focus on that major change from having 5 majority voting to this label and review framework. We just had people label 6 test videos, and we timed the amount, we timed how long it took them to go through that video, and we found the time in seconds per label. And we found that between the 2 different systems of 5 majority voting and labeling and review, we were able to save a lot of time per label. So this is getting towards our goal of efficiency as well. So in conclusion, we developed Viola, and we used a labeling and reviewing framework to try to make sure that we're getting accurate, exhaustive labels. We kept it secure by using a password to protect it and keeping it off a large crowdsourcing website and having just a small group of people label. And we also have a labeling interface that can be used for difficult video data, perhaps even other domains that might use thermal infrared data, for example. Using this, we were able to label 70 videos, which gave us approximately 180,000 individual bounding boxes, which we were then able to use to train a deep learning algorithm, which is now helping automatically detect wildlife and poachers in near real time. And our goal is to develop this further to improve accuracy and also to make it real time in the future. And so with that, this is my email. Please feel free to contact me with any questions. Also, feel free to check out our website, case.usc.edu. I actually have to run after this presentation to catch a plane, so I'll take a few questions right now, but otherwise, please contact me via email.
Let's give her a round of applause. Thank you. Now, Elizabeth did finish 2 minutes early. We have a question on the way back.
Considering the video comes in through a drone or something, do you upload that to a server and then sort of use an AWS or something to do the deep learning? Because all these things take a lot of resources. I'm guessing you don't have the servers in Africa to do this. How do you manage those resources?
Right, so the video is live streamed to the base station where people are watching it using radio waves. And then from there, they're just watching it overnight. And then after their mission is done, they then upload it to some server that they manage. They have used Microsoft Azure in the past, I believe. And then at that point, they just send us raw videos that are in MP4 format, and we do the rest with the labeling after that.
So if for this to work in real time, do you intend a system such that the drone captures it and then the system is sort of scanning it in real time and then sending out alerts almost instantaneously?
So the goal in doing it real time is to just be displaying these kinds of labels while the video is coming in. And we're doing this in the field by using Microsoft Azure to do all of the processing of the deep learning model, and then we're just sending it back and displaying it. And in case there's a poor network connection, Air Shepherd also has access to a GPU laptop, so we're able to still be able to do it in near real time, just in case the network isn't great.
Thank you very much, Elizabeth. And I hope you make your flight.
Thank you so much.
Our next paper will be presented by Tomasz Ostwald. Tomasz is the founder of Salient Works, but I should also mention he spent most of his career focused on information security at Microsoft. Tomasz.
Okay. Good afternoon. It's great to be here today. Thank you. I will need this. I want to talk today about our decision processes, which are becoming more data-driven in individual, group, and global scope. This is natural and good change. It gives us hope that our decisions one day may become rational. This change is possible because three major elements. We have much more data. We have algorithms and models, which are useful in practice. And we have, last but not least, we have computing resources to use them in practice. Those elements, we should think about them together as a foundation upon which we can build our decision processes. So when we talk about data-driven decision processes, we are talking, in fact, about socio-technical system, which consists of at least two levels. We have our decision processes with all social economic dimensions. And we have our data analysis level, which software and other technical components required to do the analysis. And we need consistency between those levels. After all, our decisions depend on results from our analysis. But in complex systems, many things can go wrong. Different elements or our socio-technical systems are susceptible to failures, which can result from errors or intentional actions of a third party. In the second case, we can talk about the threats against our decision processes, which can be defined as any activity intended to disrupt those processes or including changing their outcome. When we talk about threats, it always, the questions come to mind, should we care? What is at stake? This is the generic area. And when we talk, we make a lot of different decisions. We accepted that some of our decisions, like consumer choices, are actually heavily influenced by analysis process outside of our control. This is essence of modern advertising. There are, however, situations when we want our decisions to be very objective, data-driven. For example, when we have multiple decision makers, shared objectives, or broad social impacts. The severity of threats depends on context or our decisions. If you find your decision important, assume somebody else will find it important as well. In security, most of the problems results from complexity, unverified assumptions, and dependency on external components. We need to understand a system in order to be able to protect. This is why we use a threat modeling, which is a method to evaluate design of any information processing system in security context. We look at the system from attacker's point of view, trying to find the way to compromise some security properties like confidentiality, integrity, or availability. Such a threat model consists of enumerated threats, and for each of them, we look at the mitigation. We look at the mitigation if the systems are sufficient or existent. If they are missing or insufficient, we can talk about design-level vulnerabilities, and we have a problem. We can use the same basic approach to make our decision processes more reliable and trustworthy. Let me give you a very quick taste of a threat modeling. This is very simple. This is a very simple model of socio-technical system, which we can use in the decision process. We have some decision makers with some shared objectives and priorities. They are using their internal analysis solution based on internal data, using some internal algorithms. In addition to that, however, they are importing data from external sources and also relying on some external analysis services. If we were about to look at this purely from security point of view, we would be primarily concerned about all the incoming data, because those data are outside of control, so we must validate them. We must check if they are consistent with the format. If we added privacy to our requirement, we would take a look at the data leaving our servers just to be sure that we are not sharing something what should stay internal. But when it comes to the data analysis scenarios, we don't care only about the format of our data. We care also about its quality. We want to be sure that they represent, describe the phenomena we are interested in as closely, as correctly to the truth as possible. Please also note that this concern, this requirement applies not only to the data we consume directly, but to all the data consumed by services we are integrating with. Moving to those, we've been hearing today a lot of very justified concerns about algorithms being biased, about models being broken. And unfortunately, we see this trend that more and more data, more and more advanced algorithms become black boxes. And again, it comes questions of trust. Will we get from those services what we hope and expect to get? Then we have decision makers, which operate under different circumstances, with different requirements, and have cognitive limitations, which also can be attacked. And this picture will get even more interesting when we will start seeing artificial intelligence agents being involved in our decision processes as active participants at some point. This will be the point when the questions about priorities and objectives of those agents will be very valid. Let's jump quickly to the possible mitigations. Again, mitigations can be technical, legal, or organizational. For generic threats, we are pretty good. We know how to store data securely, how to transfer them. However, for new scenarios, for data analysis scenarios, for socio-technical context, we need to research them. Let's jump very quickly for some examples. Here, when we want to use some data, we need to think about where those data are coming from, how they were transformed. Again, can we trust them? If we want, we can do something actively. We can use data from multiple sources and compare results, reject all the anomalies. The same approach can be used in the case of models. In this case, we can additionally check specific models and algorithms on our own. But again, this is expensive. And in case of black box models, may not be very effective. So at some point, we will have to think about independent certifications, maybe about completely different new types of service level agreements focused specifically on data analysis scenarios. When it comes to decision makers, we have great opportunity to grow in the context of designing analysis user experience, very specifically in decision context. And with AI agents, again, I'm pretty sure this area is new, and it will surprise us with brand new threats. But even now, we can start thinking about repudiation, for example, about monitoring those interactions, limiting them in some scope. We need to design our decision processes to be reliable, trustworthy, and resistant to attack. In order to do that, we need to understand the goals and assets of our decision processes. We can use those to define functional requirements to the underlying data analysis and make informed decisions about selection of specific data sources and external data analysis services. We can use the threat modeling for this, but again, it needs to be adapted to the nature of socio-technical systems and nature and types of new threats which we haven't seen yet. That was, of course, the long-term goal, but there are also things which we can do in the short term. Again, don't focus on opportunities and benefits. Lessons from information security are very real. The context of our decisions, it will tell us how much, in fact, we should be concerned. Every time you are choosing a data source, think about it as a decision about design of your system. Uncomfortable questions, amazing thing in context of security. Simply ask your analysis service provider, what happens to my data when analysis is done? Is my input data and the results immediately removed from all your servers? Uncomfortable questions can be very useful also when something seems too good to be true. Always go after it. And documentation. If everything else fails, we will have a lesson to learn. To close, security in general, security efforts in nature are the continuous. New threats, new technologies enable new scenarios, which leads to new threats, which may require new mitigations. Data-driven decision processes will get much and more complex with new technologies. But it's not the technologies changes which are more interesting. It's changes caused by technologies. In just a few years, we've seen internet and mobile devices changed in a fundamental way the way we communicate with each other. We can expect the change of the same scale caused by data analysis technologies to our decision processes. We need to monitor those changes, and we cannot focus only on benefits and opportunities. If we do, we can find that our decision processes are very effective, but not longer aligned with our goals. Thank you.
Arnaud is one of the founders, along with Gideon Mann and myself, of the Data for Good exchange. And he will be talking about birds in the cloud, data engineering adventures. He's currently the director of the Foundry at Cornell Tech, the new facility being built on Rosaveta Island. Arnaud.
Thank you. Being on the program committee is a blessing and a curse. You have to review a lot of papers, but before you get all the papers, you are scared that no papers will be there, so you have to, write your own. But I can guarantee you that this paper was reviewed with the exact, same level of, scrutiny. So this is some joint work with the Cornell Lab of Ornithology. So if you happen to be near Ithaca, I strongly recommend that you spend some time with them. They have amazing specimens of dead birds, mostly. This is Cornell Tech, which is over there. So this is absolutely amazing. So after the conference, take the tram, go over the island and back. It's just like one swipe of your Metro card, and you're good to go. And this is the logo of my team. So the name of my team is called the Foundry. So we are kind of unusual. We are a team of product people, UX people, and software engineers. And we are trying to help academic research be more impactful. And the context of this work, I was visiting the lab of ornithology, and I just asked them, OK, how can I make your life a little bit less miserable? And they told me about their data pipeline. And then I had the opportunity to bring an intern, and this is the story I'm going to tell you. OK, so first, let's start with what I call the inconvenient truth about data science. So it's great. It's fun. It can be very impactful. So how many of you were attending the keynote speech this morning about sudden infant death? I mean, I don't think there is any more impactful research. But it does cost money. So the guy this morning from Microsoft, he climbed to the Mount Kilimanjaro to raise money, and he was complaining that he doesn't have enough money. So the point of this talk, it's a little bit like the Geico commercial. So for people in the US, 15 minutes can save you 15% or more. So here, 7 minutes of your undivided attention can maybe save you like $15,000. And last but not least, we live in troubled times where funding, especially coming from the government, might go away. So this is always good to be smart about that. So once again, this talk is not so much about the science. It's about how to save a few bucks when you need to do some data science. Do you remember? No? Anybody can tell me which movie? Indiana Jones Last Crusade. OK, so I don't care necessarily about birds, but when you think that birds can be a very strong signal about climate change, then I really pay attention. So this is the Ebert Project out of Lab of Ornithology. So this is a citizen science project. Mostly this is an app that you can use in order to take pictures of birds. And what the app does, the app is collecting data. They also are using machine learning algorithm to recognize the species of the bird, which is super useful. And they are using this data to make the machine learning algorithm better, but they are also using the data for much more. So today, they are covering more than 10,000 species. They have 300 million observations, and they have more than 300,000 contributors. So this is like a great example of citizen science. OK, this is an animated GIF. So out of this data, what they do, they create the migration pattern of birds. In this case, this is a barn swallow. I should have put a picture of the bird. My apologies. But as you can see, birds are moving from North America to South America. And over here, you have the time of the year. And for bird enthusiasts, this is very important. But for people who care about climate change, it could be very interesting to see how this pattern evolves over the years. OK, so The way this is constructed is using what they call a STEM model. So what they do whenever you record some observation, they try to gather tons of information about like the time of the day, the nature of the environment. Is it like, high forest, low forest? They gather, a bunch of weather prediction and things like that. And what they are trying to do, they are trying to take this base data in order to make predictions for locations where they don't have any observations. The model is trained one species at a time. And what's interesting is what they do, they look at locations in terms of space, and they also create like a time interval. So this is like a 3D cube, which is called a stixel, and I will show you exactly how it works. So let's look at all of these guys. They are observations. So this is like at a given point in time, for a given species, I observed 5 samples of the species. So what we do, we map this into the stixels, which are like space and time cubes. Then what you do for a given cube where you have all this information, you create a model. And then what you do for a location, space location where you don't have any information, you look at all the surrounding stixels, you merge all the models, and this is your prediction. Okay? So as you can see, this is something that can be very easily parallelized, and this is very convenient. So what they were doing before we intervened, they had 50 million unique space-time location. They were running something on Spark. Spark is MapReduce-like framework that you can run on your favorite cloud. And the story. And before I tell you the story, a caveat. So this is based on what happened. I'm not judging clouds. I don't want to look like the jerk who is saying that Azure is bad, because this morning everything was done as Azure. So we started with the high-performance cluster, which means that a machine running on your desktop, and the cost of running this computation was $192. Then they chose to migrate to Azure, and the cost went up. And then we started to jump in, and we used first AWS. EMR stands for Elastic MapReduce. Doesn't really matter. We managed to bring the cost to $180. And then we discovered that there is something magical called spot instances. Here, you ask for resources that are going to be yours 24/7 available to you. For this kind of computation, you don't really care. With spot instances, there is a marketplace of resources that people cannot necessarily use. So we managed to reduce the cost to $70. And then the intern who was working on the project found a very cool tool that pretty much can replace this. And we managed to bring the cost to 25. So as you can see, from 192 to 374 to 25. So depending on how you look at the data, you can reduce the cost by a factor of 10, which is huge. So what are the lessons learned? And this is like why I talked about the ICO. So the cloud is really your friend. So that's forget about buying some very expensive equipment that might be used for a short period of time, and when you really need it, you don't have enough. So use the cloud. Compare, experiment, shop. So something we learned is there are some locations of data centers where for the exact same resources at the exact same time of the day, the prices are going up. So do some experiment and you can save a few bucks. Make sure you understand your computation. The more parallelized your computation can be, the better off you are. Amdahl's law, so if you take engineering classes, you are forced to learn about that. It means that even if you optimize to the max, you are only going to optimize the part of the computation that you are optimizing. And so if you can divide by 2 the cost of this part, it doesn't mean that you are going to divide by 2 the cost of everything. Make sure you understand what you optimize for. So in our case, we looked at what they had. They had like a Spark framework using R. R is a statistical language. If you like programming languages, this is probably like the worst language you can think of because there are no types. So our first reaction was, hey, why don't we rewrite everything using like Java, Python, or whatever you want? And that was not a good approach because they are the gatekeepers of the science. And so they want to be able to make some changes. And so we had to stick to R. So understand what you optimize for. In this case, it was making sure that they can still make a lot of work. Early optimization, the root of all evil. As I said, my first intuition was, let's rewrite everything. No, bad idea. Another also interesting point is if you look at the numbers, the solution that is actually used in production is not this one. it's this one, because we are using this open source tool, which is really great, but a little bit too much bleeding edge, which is not what the lab of ornithology wanted to use. So they are willing to pay a small premium for peace of mind and making sure everything is fine. Okay, just to give you some numbers in context. So for 1,000 species, the cost saving is $130. Okay, you can do the math. That's pretty substantial. Especially if you know that they need to run this kind of computation maybe more than once a year. That's pretty much like the price of what, 1 or 2 postdocs. So by just doing this kind of stuff, you can bring like 2 more people to work for you. That's important. Okay, I have 49 seconds to conclude. So citizen science plus cloud, I think it's a new pillar of research. Ebert is a really good example. The other project that we saw during this session and more widely during all the tracks are a good example. Sometimes there is more than meet the eye, so I don't care about birds, but replace birds by climate change, and then you can get more inspired. I think that investing in data engineering is a very sound investment, which means you might want to send your research scientists to data engineering classes, or you might want to bring interns. In my case, it was an intern. Your clock is broken right now, which is good news for me. So bring some people with some data engineering skills into your team to do pretty much what we did. I think that sharing tips, this is what I am modestly trying to do today, I think is very important with the community. And I think that also working with cloud providers to make sure that they understand what we need is critical. And I have no more time. Thank you.
You were in first place for smiles in the crowd. Our next speaker is Michael Manley. Michael is the CTO of Public Goods Software and is going to talk about journalistic article analysis. Michael.
Thank you. Wrong way. So Public Good was founded in 2013 by some alumni from the Obama for America campaign. That's our chairman with the old boss. And what we were founded for was to apply the tactics from the campaign about engaging and mobilizing volunteers, and wanted to apply that to the 1.5 million 501c3 organizations in the United States. In order to do this, we ended up building a marketplace for cause-based actions. And we surface these actions during repeated contact with people who indicate an interest in a cause through email or social media or organizational outreach, but we initiate the contact through interactive experiences that are attached to journalistic articles. And the simplest form of this is up there in the left is the Take Action button, which gets embedded inside an article and leads somebody to a page on publicgood.com. Below that, we have these action cards for volunteer and donate and share your story, those kind of things. And then we also have 2 conversational interfaces in English and Spanish, which are also embedded inside the pages. Eventually are going to be in every messenger out there. With the action cards and the conversational interfaces, the reader doesn't even have to leave the media properties or the media partner's property to complete their action. These are the publishers that are using the Take Action. We work with quite a few of them. We're adding more every month. In 2016, we surfaced about 20 million Take Action experiences. This year, we'll do about 60 million. And as an example of the impact that this has, this summer the group Life After Hate lost a $400,000 federal grant due to you-know-who. And in 2 weeks, thanks to Samantha Bee promoting their presence on our platform, we raised $300,000 for them, gaining almost all of what they lost back. When you work with newsrooms that publish this kind of volume and breadth of content, you have to surface actions really quickly and accurately. And so we have to answer a couple questions to do so. First, how do we match an article to its underlying causes? Here we have an article from PRI about the Barcelona attack, and the underlying cause is the fight against terrorism, intervention, de-radicalization, and cross-cultural outreach. And the second question is, how do we match those causes to relevant organizations and relevant actions for the reader offered by those organizations? And this is an example of the kind of page that the Take Action button might direct an individual to on publicgood.com. We have to know what an organization works on and where it does its work. In order to make this scale, we have to answer these questions really fast. We have to answer them as infrequently as possible, and preferably without any humans, because they are expensive and they are slow, but they are pretty good at dealing with the corner cases. And so we try to use them only at the beginning of this process, so upfront analysis of a publication as a whole, or at the end to validate what the machine is doing. Our first foray into automating this analysis was not terribly successful. We used a single taxonomy of causes based on the IRS 990 filing data. We did entity and geographic term and sentiment extraction using Alchemy API services, and we queried a simple search index to attempt to match unextracted terms. This led to our matching being accurate no better than random chance. There were very high levels of human intervention necessary, high incidence of the widgets being hidden due to the lack of relevant matches, and really publicly embarrassing results like all articles with United States in the title matching to Gulf causes. We had strange things happen. So we had software strategies that we put in place. First, we used content fingerprinting. We had to stop analyzing the same story multiple times. Stories get edited for typos and headline changes. They get syndicated within and between publications, and they do not get canonical URLs attached. So they repeat. So we adopted an implementation of Moses Cherkar's SIMHASH technique to identify duplicate content, and that lowered the analysis load by about 25%. Next, we implemented a boring old business rules engine. This is one place where we make the most effective use of human analysis. We look at the clues in the article text, URL structure, content metadata, publisher tagging, entity extraction results, and event-specific terms. We take all these facts and run them against multiple sets of production rules and match content to causes and causes to organizations. As it turns out, modeling the world is messy. We can't rely on taxonomies created by the IRS at the beginning of the last century, or from the news industry or the UN's developmental programs. We have to look at all of them in concert, and constellations of results from multiple models. So we need a lot more metadata attached to both articles and to our own marketplace entities. And this is another place where we use the humans to do this descriptive tagging. Machine learning is the last thing that we do. Basically, we use a lot of machine learning. You can read about them in the paper. But for 100 unique articles, we can match 50 using the rules. We can get about another 80% of what's left matched by machine learning. Leaves about 10% for humans to curate, and that we can make our readers do for us. So if you read our paper, we want anyone starting down this road to learn from our mistakes that AI and machine learning are not magic pixie dust. There will always be a need for human curation and analysis. Use the humans where they do the most good in the least time. That publishers need to invest in the semantic web if they want scalable, automated discovery of their content. And the nonprofit world needs more useful categorization schemes that reflect real-world causes. That's it. Thanks.
Which brings us to our last speaker, who joins us from Mozambique. Gary Allport is in the CEO's office at BirdLife International and will talk about global biodiversity.
Good afternoon, everyone. So first of all, the bad news is that the data guy couldn't make it. So you've got me. I'm a policy guy, not a data guy. So unusually for me, I'm actually going to be reading the presentation, so forgive me. So this is a very long title for a very short talk. So this is it in brief. IBAT. So IBAT is not, as some people might tell you, Apple does baseball. It is the Integrated Biodiversity Assessment Tool. And that's what I'm going to be talking about in the remaining, 4 minutes and 30 seconds. So IBAT is a tool that was brought together as an authoritative source of biodiversity data. It's a series of tools that make sense of these data, and it's a vehicle to achieve a common vision around biodiversity knowledge for it to be used to improve decision-making and sustainable development. Accessing consistent global biodiversity data was very, very difficult. And the tool was developed with businesses, financial institutions, governments to try and solve this problem. A typical question was, does our company operate in a sensitive biodiversity area? And IBAT actually provides the answers to these. These data sets are expensive. They cost about $6.5 million a year across the organizations. And IBAT does help in providing finance for some of those costs. So it's a collaboration of 4 organizations. I work for BirdLife International, but I'm making this presentation on behalf of all 4, BirdLife International, Conservation International, IUCN, and UNEP WCMC, who are the data holders. All the data are global, and they are consistent, and they come from organizations that have a core remit to maintain the data to the best of their ability. And in fact, their interest goes way beyond just IBAT. So there is considerable investment in making sure that this data is of the highest quality. So this is the tool. This is the, there isn't really time to show you everything that the IBAT can do, but this screenshot shows you the map view, which is like the principal view of the tool. This is the World Bank Group's version of IBAT. And there are a number of different layers, globally threatened species, distributions, protected areas, key biodiversity areas, and the layers can be analyzed and downloaded, and all map data links to the information base that the organizational websites are built into this. So you can go into the protected planet, the IUCN Red List, and the BirdLife Data Zone to get important bird areas and other information. But you can also put user-defined sites of interest into the tool when you're using it and generate bespoke reports that can give you information on those locations. There are hundreds now of academics and NGO staff that use what we call IBAT for research and conservation, which is like a free version of the tool. Then there's governmental use. So this is a tool that a piece of the tool that we've developed to give information on national biodiversity strategies and action plans so that governments can plan according to the Convention on Biological Diversity at a national level more easily. Businesses use the tool for early screening over here. So, for instance, this is an example of a screenshot from Wichita in the United States for giving a circle of influence around a potential project site, and then shows the intersection with a key biodiversity area that's nearby. And then financial institutions like the World Bank use IBAT to make lending decisions. And the International Finance Corporation has its own version of IBAT in order to be consistent with their own internal standards on the environment. So with the tool comes many challenges. We've been operating it now for, I think, nearly 10 years. And the sorts of questions that are now in our mind are the data consistently good enough at a global level? Are the data and tools providing what stakeholders want? And are similar tools doing the same things or better? However, the key challenges are the interplay between the need for fund acquisition and the compilation of the data and the quality control. And we have to balance by a combination of, do we make it available free and get high level of use, or do we put a paywall in it and have relatively low use? And I think all of the organizations are basically after impact. So we have a new business plan, which really 3 main pieces to this. So we're interested now in removing the kind of style of subscriptions that we've used to date. There will also be different account types coming up, whereby there will be free users, there will be enhanced and pro enterprise versions of the tool. We'll be providing kind of bespoke, small user-defined subsets of data on a kind of pay-as-you-go basis, because that's very important for environmental consultants. And finally, central to the business plan is that the underlying data sets continue to represent the most up-to-date, authoritative, consistent global biodiversity data sets out there. And that's really important to us. Thank you.